Hello, in this lesson, I want you to use Pascal's triangle to expand the powers of binomials. I want you to use the binomial theorem to expand the powers of binomials. And the vocabulary you're going to come across is Pascal's triangle. Pascal's triangle is invented by a mathematician named Blaise Pascal, and it has many uses. We're going to look at how it works with binomials today, and also has to do with probability. And what happens on Pascal's triangle, notice on the outside of the triangles, they're always ones. Each row you have, to find the next term, we add those first two terms, and that'll give you the one below it. So for example, if I take 1 plus 1, I get 2. That's where the 2 comes from. If I look a little bit further down in my row, if I take 21 plus 35, that gives me 56. We use Pascal's triangle because these are the coefficients when you multiply a binomial out. So if I have a plus b to the 0 power, or x plus y to the 0 power, we usually have to have x's and y's, I guess, that's going to be just 1, because we know anything to the 0 power is 1. Then in row 1, that would be x plus y to the first power. That would be 1x plus 1y. In row 2, I'd have x squared, 1x squared, plus 2xy plus y squared. So each one gives us a coefficient of our terms. So if I'm going to use Pascal's triangle to expand a plus b to the 5th power. So what I'm going to do is I'm going to go down to row 5 here. And those are going to be my coefficients. So I start here with 1. I want to take the first one. That'll be a. So it'll be 1. I'm not going to write 1, but it's 1a to the 5th power. Then every time I go to a term, a new term, I'm going to reduce my exponent of the a by 1 and increase the exponent of the b times 0. So right now it's a to the 5th, b to the 0. Plus my second term in my row is 5. So I'm going to say plus 5 times a to the 4th, and that'll be b to the 1st. Plus my next term is 10. So my coefficient is 10. A to the 3rd, b squared. And then 10 again, because it's symmetrical. A squared, b cubed. Plus 5, a to the 4th. Whoops, went the wrong way there, didn't I? Plus a, b to the 4th. And then finally, plus 1, b to the 5th. I can use Pascal's triangle to answer questions related to probability. And here's what we're going to take a look at. It says, find the probability of having 6 lambs with white wool and 2 lambs with black wool. Now, this is a simple problem. We only have white and black. You can't have any other colors. We're going to expand the binomial w plus b to the 8th. I want to look at the term that has white to the 6th and black to the 2nd. So what happens is I'm going to use row 8 of Pascal's triangle. So I'm going to go back here. I'm going to erase this. I'm going to highlight row 8. In fact, I think I'll write it down here. So here's row 5, 6, 7, and 8. Now what happens is your first term is going to be w to the 8th power. So if I look at my first term, that's w to the 8th. Here's w to the 7th. Here's w to the 6th. So my coefficient is 28. That's what I'm looking for. So I'm going to have 28. Now out of what? Well, then I'm just doing, I have 8 ways of picking lambs, and I got black and white, so I'm going to have 2 to the 8th power. So I get 28 over 2 to the 8th. Use your calculator there. 2 to the 8th, I think that's 256. And then let's reduce that And let me see, what goes into both 28 and 256? I think 4 does. So if I take 28 divided by 4, I get 7. 256 divided by 4 is 64. So the probability of having 6 white wool lambs and 2 black lambs is going to be 7 over 64. A lot of times we like to write probability as decimals. So I'll just take 7 divided by 64, and we get 0.109. Or as a percent, 10.9%. You can do it however you want.